A very good evening to everyone. My name is Sanjana Gulaya and this is my video for the fourth task that was given to me as a data science and business analytics intern at the Sparks Foundation. The objective of this task was to perform exploratory data analysis on the dataset which was given to us as global terrorism. The code for this project is also available in my GitHub repository, for which I've included a link over here, and I've also included a QR code which you can scan as always, and it'll take you to my repository page. Now, before I go to the code, I'll just quickly take you to the data set to give you a rough idea as to what we're dealing with. So this is the data set that was given to us. It's a CSV file called Global Terrorism. Uh, so this is probably the largest data set that I've ever worked with, and the reason behind this is because it has more than 1,81,000 entries in it, and it has 135 columns. So it's a pretty large data set, and so it's precisely the reason we'll have to sort of perform some data pre-processing and data cleaning to make the data set more useful to our purposes and sort of restricted to the scope of this project of analysis. So I'll quickly list out the features that are of importance to us. We firstly have the year, which is ranging from 1970 to 2017. So we'll be seeing the trend of terrorist attacks over the year. Then we have the country, the region, city. Then we focus on casualties, if people were killed or the people were wounded. Then we talk about the type of assassination, the type of attack, sorry, whether it was an assassination, a bombing or explosion, an armed assault, so on and so forth. And then we talk about the targets of the attack, whether it was a private citizen or private property, whether it was a government official, whether it was a journalist, military personnel, a police officer, or so on and so forth. Now we can jump to the Jupyter Notebook and go through the code. So as I explained in my previous video as well, for these data analytics projects, I'm not going to be using Tableau, I'm using Python itself. And within Python, I'm using Cufflinks and Plotly, which are, as I told, really cool libraries with which you can create these interactive plots which make data analytics much more interesting. So we could just begin the code by reading the CSV file, global terrorism. A point to remember over here for my fellow interns who might be facing a little bit of issue in terms of reading the CSV file, you will have to set the encoding equal to Latin 1 to be able to read all of the city names that are given to us. Without this, you might be facing an issue, so hopefully this should fix your issue. If we check the head of the data frame as expected, we can see 5 rows and 135 columns. We can also call the .info and .describe method to get some useful features from our data set. For example, the type of all of the entries, then the count, mean, median, minimum value, maximum value, so on and so forth. And now we come to the data pre-processing part. Firstly, what I've done is I've added a column to our data frame called casualties. And if you would have seen in the data set, N kill and N wound are basically columns that carry binary values 0 and 1. And so if we call this column casualties, it basically just gives us a combined value of 0, 1, whether there were people wounded or people killed. And this makes it easier for us to sort of plot it as one plot rather than two different plots. Next, what we do is we drop any duplicate rows that we have using this command. However, if we check the data frame after calling this command, we see that the number of rows is still the same. So there weren't any duplicate columns, which just shows that it's a good verified source of information that we've got this data set from. I've kept the original data frame for reasons that I'll use later on. Next, what we do is we run through a for loop through all of the columns, and we basically drop any columns that had more than 10,000 values. So in case you have missing values, one way to deal with it is by filling in the mean value or so on and so forth. You can do that, or if you have too many null values in your data set, you can just drop the column. So I've done that, and after that, if we check the columns, we can see that we have just 45 columns, and it has more or less all of the columns that were relevant to us for performing this data analysis. Now we can begin with the EDA. Firstly, we plot out a graph which shows the number of terrorist attacks versus the years. So we can see over here it's a rising trend from 1970 towards 2014, and we have a maximum at 2014 with 16,903 attacks that year, and then we have a steady decline towards 2017, which is the end of our data frame. So more or less it's a rising trend over here. As we can see, and with Plotly we can just sort of hover over these bars which will give us the exact value of that country. Next, what we do is we check out the top 10 countries which are sort of, you can say, the hotspots of terrorist attacks, and standalone we have Iraq over here as the highest number of terrorist attacks in our data set with 24,636 entries to its name. Then we have Pakistan, Afghanistan, India, so on and so forth. Next, what we aim to do is we sort of plot out all of the countries versus the number of attacks they've had, and we can see the single bar over here, which is Iraq, which is the highest, as we saw in our dot value counts method as well. And because there are so many countries, obviously all the names are not visible, so we can use the zoom in feature to sort of zoom in and see a few of the countries that are not very clearly visible. I'll just zoom in. Yeah, so if we zoom in over here, now we can see it a little bit more clearly. Pakistan over here, Colombia over here, which is the third highest, and Austria over here, and then we can just auto scale back to our original plot. What I've done next is I've plotted out this a similar plot for all of the cities in a few important countries. Firstly, we've done it for India, and in India we just check out. Firstly, we have Srinagar as the highest, and then we have unknown, which is basically a column which people filled in the data set for not knowing where the attack was. So we can just ignore that. So after Srinagar, we have Imphal and then New Delhi. So if we can just see this in the graph as well, we have this very huge spike in our graph over here, but it's not really clearly visible what the city name is. So we can zoom in a bit over here and check out which place this is. So I'll zoom in a bit more. Yeah, this is better. So we can see over here, Srinagar over here is the highest as expected with 658 attacks to its name. Then a lot of other cities are there which are pretty low in count. So we can we don't need to really focus on them. We need to focus on the hotspots of all of these attacks. So in India, the highest city would be Srinagar. So as defense or maybe security analyst, this should be our main area of focus. Next, I've done the same for the United States of America, and we can see a single huge spike over here. And if we sort of hover over it, we can see that this is New York City with 460 entries to its name. And then if we want to see a few more cities a bit more clearly, we can just zoom in a bit over here. We have Miami in this zoomed in photo as the largest. We have Phoenix, which is pretty low. Few more cities that are pretty low, so we don't really need to focus on them. We just need to focus on the hotspots of these terrorist attacks. Next, what I've aimed to do is I've created a choropleth map, which is one of a very few interesting data analytics plots that we have. A choropleth map is sort of a geographical plot that you can do for either a country or for the entire globe. And what it does, it takes in these values of data and layout as dictionaries, and then it plots them out on map, so to say. So you can hover over here over India, and it'll give you the value of terrorism attacks for India, and then you can zoom out, zoom in, rotate the globe sort of. Over here, Brazil stands for BRA. So we have a few country codes that I've imported from another data set. Moving on, what we can do is we can analyze the attack types that we had. So we have a few columns over here, bombing and explosion being the largest attack type with 88,000 entries to its name. So if we just plot out an eye plot, which is an interactive plot, we see this graph over here. So we need to focus our preventative measures towards bombing and explosion intelligence, and this is what we can see from this graph. Next, what we do is we sort of I'll just zoom out over here. Yeah, we can we can group by the attack type and then plot out the casualties as well for various types of attack types. So as expected, I've set ascending to false. So basically the highest casualties that we have as expected can be from bombing or explosion type of terrorism attacks, followed by armed assault. So as analysts, security analysts, we need to focus on intelligence of preventing these kind of terrorism attacks which cause highest number of casualties. Next, what we can do is we can also plot out the target types that we had. So unfortunately, in these kind of situations, what happens is private citizens or innocent bystanders are the ones attacked the most. So we have the highest being private citizens and private properties, followed by military people. Then we have police personnel and so on and so forth. We can see these target types over here plotted out. So we need to focus on sort of the larger or the taller bars over here. What we can do next is we can also plot out the number of attacks on the basis of region, and then we can focus our preventative measures on the regions that we have. So as you can see, the single largest bar over here is Middle East and North Africa, followed by South Asia. So these are the sort of hotspot regions wherein most of the terrorist attacks take place. Next, what we do is we also can see the weapon types that are used in most terrorist attacks, and largely we have explosives being the highest, followed by firearms. So we can also sort of uh, think and plan for these weapon types. Next, what I've done is I've plotted out two plots, line plots, basically interactive plots, showing basically all of the regions that we have versus all of the years that we've had, and we'll have to zoom out a little to be able to see most of them. Yeah. So if we zoom in to this area, we can just see these line plots for various regions versus the year over here. And then what I've done next is I've done something similar for the target type, and that's basically you can just hover over these lines to check out the target type versus the year, and then you can zoom in to check out the values more clearly. So that's it for this data analytics project. Thank you very much for watching.